Have you ever really watched something grow? I mean, a plant doesn't just wake up one morning an inch taller, right? It grows continuously, smoothly, every single second. Well, it turns out nature has a special language to describe that kind of perfect, unbroken growth. And it all revolves around one single, kind of mysterious and incredibly powerful number. Let's go find out what it is.
So, to crack this mystery, we're going to take a pretty surprising path. Our journey is going to start with a simple story about a magical bank account, which, believe it or not, leads us straight to this magic number. From there, we'll uncover its unique superpower and then see how it's secretly running things all around us, from growth to decay.
So yeah, let's start with that big question. When something is growing, and that growth is happening at every single instant, not in little jumps, but just smoothly, how do you even begin to talk about that with math? Well, the answer, amazingly, is a single number, a constant known as E. You could almost think of it as the signature of continuous change in the universe. And to understand where it even comes from, our story doesn't start in a biology lab, but with a simple question about money. That's right, the whole story of this fundamental constant of nature actually begins with a little thought experiment about money and interest. It sounds strange, but stick with me. Okay, so picture this. You find a bank with a deal that is just way too good to be true. You deposit just $1. That's it, and they promise to give you 100% interest on it over 1 year. I mean, what a deal. So let's start with the simplest possible case. The bank pays you all that interest in one big lump sum right at the end of the year. After 365 days, how much money is in your account? Yep, you'd have your original dollar plus another dollar from that 100% interest. Your grand total is $2. Simple enough, right? But what if you ask the bank to get a little clever? Instead of paying it all at once, they agree to pay half the interest, so 50%, after 6 months, and then the other half at the end of the year. So, do you think you'll end up with more money, less, or the exact same $2? Let's break it down. After those first 6 months, the bank takes a look. You've got $1 in there, and they add 50% of that, which is 50 cents. Your new balance halfway through the year is now $1.50. Now, here's where the magic of compounding kicks in. For the second half of the year, the bank calculates that 50% interest, but not on your original dollar. No, it's on your new total of $1.50. So they add another 75 cents. Your $1.50 plus that 75 cents gives you a brand new grand total. And that total is $2.25. So just by splitting up the interest payment, you've made an extra 25 cents. This is the whole key. You're now earning interest on your interest. This, of course, leads to a new question. If compounding twice a year gives us more money, well, what happens if we just keep going? I mean, what if we compound quarterly or monthly? What if we push it to the absolute limit and calculate the interest every single day, every minute, every instant? Does the money just grow to infinity? Do you become infinitely rich? And what we find is absolutely fascinating. Take a look at this pattern. As we crank up the compounding frequency, the final amount does go up, but the gains get smaller and smaller. The jump from once a year to twice a year gives you a whole 25 cents. But look at the jump from quarterly to daily. That's hundreds more calculations, and it only adds about 27 cents. The total isn't racing towards infinity, it's closing in on a very specific number. And that limit, the absolute maximum amount of money you could possibly earn, is the number we've been looking for. It's E, which is approximately 2.71828. It's the pure result of perfect, 100% growth that's happening continuously at every single moment in time. It's pretty amazing that we found this number hiding in a bank account problem. But the reason E is so critical in science and nature, well, it has nothing to do with money. It's all about its unique, almost magical superpower. So here's that superpower. If you look at a growth curve described by the number E, it has a property that no other number has. At any given point on that curve, its current value, how big it is exactly equal to its current rate of growth, how fast it's growing. Its size is its speed. It's a perfect match. Let's make that a little more concrete. At a point where the value is about 2.718, its rate of growth is also 2.718. When the value grows to about 7.389, the growth rate instantly matches it, also becoming 7.389. This is the whole idea. The bigger it gets, the faster it grows in a perfect one-to-one relationship. And this perfect relationship between size and speed isn't just some mathematical curiosity. It's actually what makes E the natural language for describing countless things we see in the real world every day.
Think about it. Where in nature does the rate of something changing depend on how much of it you currently have? A population of bacteria is a perfect example. The more bacteria you have, the faster the total population reproduces and grows. And it works in reverse too. With radioactive decay, the rate at which atoms decay is directly proportional to how much stuff you have left. A big chunk decays quickly, a tiny piece decays slowly. Both are governed by E. So just think about where we started, a simple question about bank interest. And that question somehow led us to a number that describes the fundamental processes of the universe. That's why E really is the universal constant for continuous change. Which, it just leaves us with a final thought. We found E in our bank accounts, in biology, in physics. But where else is it hiding? What other parts of our world, from the curve of a seashell to the way a story goes viral, are secretly being run by this one magic number?